So hello students, this is experiment number 2. So here thermal conduction in composite wall. Okay, so here you can see first dimmer state to vary voltage in our voltmeter is connected, then voltmeter and ammeter it is connected with heater coil, and then thermal indicator is there, okay, to observe the various temperature. Now we have to observe the setup. So in this setup you can see at just middle of this plate heater is arranged here. Okay, so at the two sides of this heater you can observe mild steel, then bakelite, this is bakelite, and this is wood. Okay, so why we arrange this mild steel 2 times, bakelite 2 times, and wood 2 times? If we arrange this mild steel, bakelite and wood, okay, in single way, in that case there will be loss, okay, from this heater side. So to reduce this loss we have arranged this setup in such a manner that the heat produced by this heater will pass through this both sides equally. So if heat is passing from this heater to outer side equally, so we have to arrange this mild steel, okay, then bakelite and wood symmetrically. So this is symmetrical arrangement of mild steel, bakelite and wood. So heat is flowing through this mild steel equally, similarly bakelite equally, and wood also. Okay, so here if we see the junction box, so in this junction box you can see T1 and T5. So what is T1 and what is T5? So where this T1 is there and where this T5 is there. So T1 and T5, if we see here, so in between this heater coil and mild steel, okay, in between this heater coil and mild steel, this is T1. In between this heater coil and right side mild steel, okay, so this is T5. Similarly T2 and T6, so where this T2 and T6 will be there? So T2 it is in between bakelite and mild steel, left side. T6 it is in between bakelite and mild steel in right side. Similarly T3 and T7, so T3 and T7, where this T3 and T7 will be there? So similarly, symmetrically if we see, so in between wood and bakelite T3, left side it will be T3. Similarly in between wood and bakelite T7 at right side. So T4 and T8, similarly T4 will be at outer surface of this left side, outer surface of this wood, there will be T4, and right side outer surface of wood will be T8. So symmetrically we have arranged this in our junction box. So when we have to take the reading, how we have to take the reading here? So first we have arranged here 60 voltage. So for this 60 voltage current is flowing 1.036 ampere. Okay, so here in junction box first we first we observe the T1 temperature. Okay, then after taking this T1 temperature you can observe here T1 temperature it is something 47 degree Celsius. So after T1 temperature, T5 temperature. So T1 and T5 these are symmetrical in nature. Okay, T1 and T5 these are symmetrical nature. This is something 52 degree Celsius. So you have to take the mean of T1 and T5. Similarly mean of T2 and T6, mean of T3 and T7, mean of T4 and T8. So in calculation part we will understand this in detail. So how we have to see the calculation of this, but we have to calculate the thermal conduction in composite wall. Okay, how this thermal conduction will occur in composite wall. So in this way we can calculate the thermal conductivity of mild steel, thermal conductivity of bakelite, and thermal conductivity of wood. Okay, so you can see this is wood, mild steel, bakelite, okay, in symmetrical nature. So in this way this setup is there. So about calculation part and observation, we will understand this later on. Okay, thank you very much. So hello students. So we have seen in previous video the setup of our thermal conductivity of composite wall. So here we first overlook about the write up, and at the same time how to do calculation part, how to take observation. Okay, then some basics. Okay, so determination of thermal conductivity of composite wall. So it is very essential engineering application everywhere about composite wall, because if you see in your household also, household application, just like in refrigerator, air conditioner, heating pipes, so everywhere you can see a different material composed. Okay, so in engineering applications we deal with many problems. Heat transfer through composite wall is one of them. Okay, so composite wall is very necessary. So it is transport of energy between two or more body of different thermal conductivity arranged in series or in parallel. So for example, fastening joining two medium also act as one of the layer between this medium. Similarly, if you see the various application area, so industrial steam pipe, the insulated pipe carrying refrigerant, wall of an air conditioning room, doors and slides of refrigerator, doors and walls of cold storage, there also you can see composite walls. So the composite walls are formed by placing layers of different material, just as your steel, copper and any other metallic walls, then concrete, then wood, then insulating materials such as asbestos, thermocouple, glass wool, PUF, cork, all these. Okay. So experimental setup, although we have seen that experimental setup, so we again see how these thermocouple arrangements are there. So composite wall consists of three discs here, that is mild steel and then bakelite and then wood. Okay, and three different material are placed on on two sides of heater to form assembly of symmetrically formed composite wall apparatus. So that part we have seen in our previous video, how this three material arranged. Okay, so in between this three material symmetrically, this three material arranged, and the center of this setup will be heater. Okay, so you can see this is our setup. Okay, so in this setup you can see this is nothing but your center of the setup. This is nothing but your heater coil. So you can see this is heater coil, and this heater coil is connected with dimmer state. This heater coil is connected with dimmer state, and it is connected with ammeter and voltmeter. Okay, so ammeter and voltmeter, dimmer state, if we vary dimmer state, so voltmeter will give voltage to this heater coil, then current will flow through this heater coil and heat will flow bidirectional. So heat will flow bidirectional. Let us assume this is our heater, so heat will equally flow in both directions, either direction. So you can see the arrangement of temperature, that part I think we have seen. So in that part we have seen that this is T1, T5. So this two temperature you can see. So T1, so T1, T5, T1, T5. You can see, sorry. So this is T1 and T5 in either direction, either side of this heater coil. So this is T1 and this is T5. Similarly, this two you can see this two mild steel plates equally arranged. So this two mild steel plate equally arranged. Okay, so after that again T2, and this is T2, and then this will be T6. Okay, so after that bakelite plate. So this is your bakelite plate, and in between bakelite and wood T3 and T7. Again after wood T4 and T8. So this is symmetrical arrangement of your setup. So okay, so this is all about the setup. Here this is your temperature junction. Okay, so this is temperature junction. You can observe the temperature in your temperature indicator. So this is about the setup. Now specification. So heater and composite wall diameter, it is 0.2 meter. Thickness of mild steel plate, it is 0.015 meter. Thickness of bakelite plate, it is 0.015 meter. Thickness of wooden disc, it will be 0.015 meter. So see, if we see the thickness, so thickness, it is nothing but this thickness. Okay, so this is heater and composite wall diameter. Directly diameter it is given, that is cross sectional area diameter, it is 0.2 meter. Thickness of mild steel, it is 0.01, so 0.01, then 0.015, sorry, 0.015, 0.015, 0.015, it is same throughout. Okay, so then dimmer stage single phase, it is 2 ampere 230 voltage capacity. So digital ammeter and digital voltmeter. So first we fix some voltage in our voltmeter. Let us assume we fix voltage 60 volt. So we have to calculate here steady state condition. Sorry, we have to observe steady state condition. To observe steady state condition, what we do? Every time we have to take at 10-minute interval of time we have to take the temperature reading. So first 0 time reading, so all the temperature we note down. Okay, similarly for after 10 minutes again we take temperature readings. Then after again 10 minutes, it is after 20 minutes, so again we take the reading. Okay, similarly after 10 minutes again we take reading. So up to how much time, how much time we will continue this? We have to take reading. Here it is written, take reading as per above table up to steady temperature for last 3 readings is achieved. Means until the 2 consecutive reading will not be same, we have to continue. Okay, so temperature, again see, we have to calculate mean reading of T1 and T5. What is T1, T5? It is temperature in between, this is temperature of mild steel in contact with heating element. So mild steel and heating element. So T1 and T5, it is mild in temperature in between heating element and mild steel. Similarly TB, it is average interface temperature in between mild steel and bakelite. So it is T2 plus T6 divided with 2. Again average interface temperature of bakelite plate, wooden plate, it is T3 plus T7 divided with 2. Then average interface temperature of wooden plate and pressure plate, it is T4 plus T8 divided with 2. So that we have to follow. Then sample calculation you can see. Again see here, because the same amount of heat it is flowing in either direction from heater coil. So we have to calculate Q by 2 here. We have to calculate Q by 2. Why? Because Q by 2 heat will flow left hand side and Q by 2 heat will flow right hand side. Okay, we have arranged mild steel, bakelite and wooden plate symmetrical. So that's why Q by 2 heat will flow in left hand side, Q by 2 heat will flow in right hand side. Okay, this is the way through which you calculate your conductivity for different slabs. Then again we have to calculate thermal conductivity of composite slab. So for thermal conductivity of composite slab means it will be equivalent thermal conductivity for all the three materials. So how I can calculate? Q by 2, it is equal to K slab. Area of cross section will be same. B will be what? The addition of all the three material, and TA and TD. Okay, so TA is what? What is TA? It is average temperature in between heater coil and mild steel. And what is TD? It is average temperature at the two extreme points. Okay, that is at outer surface of your wood. So in this way I can calculate the thermal conductivity of individual material. At the same time I can calculate thermal conductivity of composite slab. So thermal resistance of mild steel, again you can calculate. Thermal resistance we know. What is thermal resistance? If we have to calculate thermal resistance, it is what? L upon K A. So this is the thermal resistance formula. So I can use here this formula. So thermal resistance of mild steel, it is B1 upon KMS, mild steel के लिए thermal conductivity into area of cross section. See here area of cross section will be same every time. Thermal resistance of bakelite plate, then thermal resistance of wooden plate, and thermal resistance of composite slab, that is the summation of R1 plus R2 plus R3. Okay, so again determination of thermal conductivity of composite slab by electrical analogy. So you can use electrical analogy also. So for electrical analogy you have to draw this diagram, then calculate this thermal resistance. Okay, so this thermal resistance in between these three different material. Okay, so this is, in this way you can calculate R for different material, and again you can calculate R for your composite slab also. So in this way this experiment can be concluded that you have to find out thermal conductivity of mild steel, thermal conductivity of bakelite, and thermal conductivity of wood, and thermal conductivity of composite slab, and draw temperature versus length plot for composite wall. Okay, one side of heater you have to assume here. Okay, draw thermal resistance network for entire composite wall. This is expected in your experimentation and write up. Okay, thank you very much.